Okay, listen, last class we are discussed about 22 questions, sorry, 21 questions are completed. Next 22nd question, let's see. Consider the following sets of quantum numbers. Which of the following set of quantum numbers is not possible? Is not possible. That we need to identify. We know that what are the n values and related to n, what are the possible L values, azimuthal quantum number, and based on that azimuthal quantum number values, m values will depend. S is independent. S value means spin quantum number is independent. It is always either plus 1 by 2 or minus 1 by 2. For one electron, it contains either plus 1 by 2 or minus 1 by 2. That is spin quantum number values. Okay, let's see the first one. N is equal to 3, L is equal to 0. N is equal to 3, L is equal to 0 means that is 3s. 3s orbital. Okay, so that m value is 0. For s orbital, m value is 0, then it is correct. Now let's see the second one. N is equal to 2 and L is equal to 2 means n value is always more than L, but n is equal to L, not possible. Okay, so that's why this is not possible. Second is not possible. Let's see third one. N is equal to 4 and L is equal to 3. L is equal to 3 means it is F. What is that? 4F. For 4F orbitals, possible m values, yes ma'am, possible m values. What are those possible m values? The possible m values are -3, -2, -1, 0, +1, +2, +3. So among these -3 to +3 range, one m value is present for one orbital, that is -2 they gave. So it is also possible, means it is correct. So the first one and third one is correct. Let's see fourth one. N is equal to 0, L is equal to 0 means that is 1s. 1s orbital, m should be 0. M is equal to 0 but not -1. That's why the fourth one is not possible. Next fifth one. N is equal to 3, L is equal to 2 means that is 3D. For 3D orbitals, the possible m values -2, -1, 0, +1, +2. But 3 not possible. This 3 is not possible. That's why fifth one is also not possible. So not possible sets are 2, second comma, fifth, sorry, fourth and fifth. Second, fourth and fifth means second option is correct. Okay, clear students? See here, quantum numbers, n values 1, 2, 3, 4, 5, like that it will be present, and L values are depends on n values. They starts from 0, 1, 2, 3 up to n minus 1, but never n is equal to L, never possible n is equal to L, always n not equal to L only, not possible, n is equal to L, and L value never more than n values. Okay, that is very clear. Next, m values depends on L values. So the possible M values are minus L up to 0 up to plus L. In this range only the M values will be present. That's why the not possible sets are 2, 4 and 5. 2, 4 and 5. Okay, clear students? All are clear? Niket, Vivek, Nishchal is there? Amruta. Next. Shravana. Shravana present ma? Shravana, observe. Absent today, Shravana? Shraddha, clear ma? Seema? Okay, understood? Yes ma? Maruti, listen carefully. Okay. Everyone listen once again. Which of the following four sets of quantum numbers they gave ma Maruti? N values, L values, M and S. Which set is not possible set we need to identify? Let's see the first one. N is equal to 3, L is equal to 0. Means it is possible. Like that, orbitals means any orbital like that quantum number is possible. Because N is equal to 3 means the possible L values are 2, 1, 0. That's why in that one 0 is present. 0 is present. That's why it is possible. Okay. Next. In the same way, M is equal to 0. For S orbital, means M value depends on L. If L is equal to 0 means there is only one M value is present, that is 0. S may be plus half or minus half. It's correct. Now, that's why first set is correct. Now let's see second set. What I said, N and L values must not equal. If they are equal means it is not possible. Here N is equal to L. That's why it is not possible. Okay, it's very clear. Next, third set you see N is 4, L is equal to 3. It's okay, it is very clear. And possible M values are in the range of minus 3 to plus 3. So in that minus 3 to plus 3 range, minus 2 is present. That's why the third set is possible set. Next, let's see fourth set. N is equal to 1, L is equal to 0 means, okay, it's very clear. L value is less than N. But M values depends on L. If L is equal to 0 means M should be 0 only. Minus 1 not possible. That's why the fourth set is not possible. Let's see the fifth set. N is equal to 3, L is equal to 2. Okay. Here L value is less than N. That's why this 3 and 2 correct only. But M value is depends on L. So L values are 2 only means the possible M values are in the range of minus 2 to plus 2. Minus 2 to plus 2. But M value is 3 they gave. That's why it is a wrong arrangement. So the fifth one is also wrong arrangement. Understood ma Maruti? Clear? Okay. Let's go for next question. Next. Let's see. Any F orbital can accumulated up to any F orbitals, not only F orbital, any one orbital has maximum 2 electrons, maximum 2 electrons with opposite spins. Opposite spin. What is that rule? According to one orbital is present in that two electrons, the two electron must should be in anti-parallel. Okay, so the answer is in one orbital has maximum 2 electrons with opposite spins. That doesn't contains parallel spin. Okay, let's see 25th, fourth. For a principal quantum number n is equal to 5, the total number of orbitals L is equal to 3 having. L is equal to 3 means n is equal to 5, L is equal to 3 means it is 5f. 5f. In 5f orbital, how many maximum number of orbitals are present, ma? That is number of orbitals in a subcell is equals to 2l plus 1. Here L is equal to 3. 2 into 3 plus 1 is equal to 7. So the answer is first one. Okay, clear? Next 25th. Hey, about 14 electrons. You don't have idea about that orbitals and electrons? What they are asked in the question? N is equal to 5, L is equal to 3. Contains total number of orbitals. So that orbitals is equal to 7 and electrons is equal to 14. Read the question perfectly. Don't confuse. Okay, let's see 25th one. Clear, Abhay? The four quantum numbers for valence electrons of potassium are. See, valence electron. What is the meaning for valence electron? Valence electron means last electron or outermost shell containing electrons. Outermost shell containing electrons known as valency electrons. Okay, potassium, it's very clear. Potassium Z is equal to 19. So it contains 19 electrons are present. Its complete electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Next, the 19 electron is present in 4s1 up to 1s2, 2s2, 2p6, 3s2, 3p6. Here 18 electrons are present. This 18 electrons is nothing but argon configuration. Argon atomic number is 18. So argon contains 18 electrons are present. Helium, neon, argon is inner shells. Then the outer shell is 4s. It contains 1 electron is present. See this 4s1 electron. Quantum numbers, 4 set of quantum numbers we need to say. N is equal to 4. Okay. And s orbital L is equal to 0. Okay. N is equal to 4. L is equal to 0. If L is equal to 0 means the possible M values is 0 and spin quantum number is equal to plus 1 by 2. One electron is present, then we have to consider the spin is plus 1 by 2 or maybe minus 1 by 2 also correct. But in the options 4 comma 0 comma 0, 4 comma 0 comma 0, 1 by 2 means like that option is present in third option. Okay, clear students? Anybody have doubt? Maruti, Amruta, Chinmay? Why second option is wrong? What is the second option? 4 comma 1 for L value, how it is possible for 1 ma abhay? Hey Abjal, why L equal to 0? What is that S orbitals? S orbital L value is always 0. For p orbitals L value is always 1. D orbitals L value is always 2. F orbitals L value is always 3. That is basic. Azimuthal quantum number values are basic. So you are not studying that basics. First read everyone basics, formulas and all concepts. This weekend means next the coming Monday chemistry exam is there. Subjective exam and objective exam. Complete syllabus on this atomic structure chapter. Okay. So the answer is third one. For S orbitals, L value is fixed. That is 0. Based on that L value, M value will be present. If L equal to 0 means M also must should be 0. If L is equal to 1, the possible. If L equal to 0 means M must should be 0. If L is equal to 1 means the possible M values are 3 values are present. Plus 1, 0, minus 1. If L is equal to 2, L is equal to 2 means that is d orbitals. L is equal to 1 means that is p. L equal to 0 means s. L is equal to 2 means the possible m values are 5 values are present. What are those? Plus 2, plus 1, 0, minus 1, minus 2 like. So this is basic concept. That concept we have to keep it in our mind. According to that we have to solve these all kind of questions. Okay. Next. 26. Basic ma. In ground state electronic configuration or in normal electronic configuration, the element which has 13 electrons present in M cell. 13 electrons present in M cell, the element is, see 13 electrons means we know that K, L, M, N, like this. K shell means N is equal to 1, L cell means N is equal to 2, M cell means N is equal to 3, N cell means N is equal to 4. In M shell, the given atoms which contains 13 electrons are present, that we have to identify. Means N is equal to 3. In third shell, which atom containing 13 electrons in the given? First one, let's see, manganese. Manganese symbol is Mn. Cobalt symbol is capital C small o. Nickel Ni. Iron Fe. Mn manganese. Atomic number Z is equal to 25. Its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. See, here in 1s means K shell. K shell contains 2 electrons, 2s and 2p. This is a second cell. L cell contains 8 electrons. Now, this the M cell is 3. N is equal to 3. That is M shell. The M cell, how many electrons are present? 2 plus 6 plus 5 is equal to 13 electrons. And this 4s means N shell. The N cell contains 2 electrons are present. In the given question, M shell, the given atoms, which atom contains 13 electrons present in M shell. So that is manganese. That is a manganese. Let's see the remaining also, we'll check. The remaining means cobalt. Cobalt, Z is equal to 27. Its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. 3d7 means the M cell contains how many electrons? 2 plus 6 plus 7. 2 plus 6 plus 7 means 15 electrons are present. The M cell contains 15 electrons are present. Two comma 5 comma 2 comma 6. Rani, how you are saying 2? N equal to 3. 3. What are the N equal to 3 containing orbitals? 3s, 3p and 3d. Count that. 2 plus 6 plus 5. 2 plus 6 plus 5 is equal to 13 electrons. And 4s. 4s is not N shell. M cell. This 4s is M cell. That I am saying 4s means it's very clear. N is equal to how much? N is equal to 4. N is equal to 4 means N shell. Don't think about that inner cells. The 4s is in middle in between the 3p and 3d means because the 4s orbital has lower energy when compared to 3d. Already we have discussed that. The electrons are not completely filled according to their first shell is after complete filling of first cell, the next electrons are goes to second cell, the next electrons are goes to third cell, the next electrons are goes to fourth cell, not exactly. So first cell is 1s is lower energy, however it will be completely filled. Then 2s and 2p, they after completion of 2s and 2p, the electrons are goes to 3s, 3p. Next the electrons are enters into the 4s, again comes to the 3d. Okay, because 3d is higher n plus l value. The energy of orbitals depends on n plus l value. 3d has more energy when compared to 4s. That's why 4s is lower energy. But 4s belongs to N shell. 3d belongs to M cell. That's why M cell containing how many electrons are present? 2 plus 6 plus 5 is equal to 13 electrons are present. Clear? Rani? See, simple logic ma, M shell means N mass should be 3. Like 3 where present 3s, 3p and 3d present. In 3s how many electrons are present? 2. And in 3p how many electrons are present? 6. And 3d how many electrons are present? 5. So you count that, then 13 electrons. Like it is very simple questions. Don't confuse. Okay? So this kind of questions also very important. For NEET and JEE and CET examination they are asking. It is one previous question. Earlier in JEE examination and CET examination this question asked. Repeatedly they are asked. It's very important. Okay. Next, cobalt has 15 electrons. In the same way, nickel. Z is equal to 28. Nickel Z is equal to 28 means the 28th electrons is present in 3d8. So 3d8 means if you are observed that 16 electrons are present. In M cell it has 16 electrons. You try once. Next, iron. Iron Z is equal to 26. Z is equal to 26 means the M shell contains 14 electrons are present. Okay. You write that electronic configuration, complete NLX method. You write its complete electronic configuration. Then each M cell contains how many electrons you count it. Sometimes not only M shell. In the given options, manganese, cobalt, nickel and iron, all there contains how many electrons present in N shell. These all are having 4s2, 4s2, 4s2 means this all contains 2 electrons is present in N shell. Manganese N cell contains 2 electrons only. Cobalt N cell contains 2 electrons only. Nickel contains 2 electrons present in N shell only. Iron also contains 2 electrons present in N shell. What is the difference for these all? The difference is the last electrons are enters into the M shell, because these all are belongs to d block elements, means the valence electrons enters into the 3d orbitals. In the manganese, the last electron is enters into 3d, that's why it becomes 3d5. Cobalt 3d7, nickel 3d8, iron 3d6. That's why their variation is present in M shell containing electrons. Okay, let's go for next question. Which combinations of quantum numbers n comma l comma m and s for an electron in an atom does not provide a permissible solution of the wave equation? Means is not possible set. We have to identify not possible set of quantum numbers. See, n equal to 3 and L is equal to 2, because L value is less than n, that's why it is possible. And M also, if L is equal to 2 means the possible M values are plus 2, plus 1, 0, minus 1, minus 2. That's why this minus 2 is also possible, and the spin is plus half, it is possible. So it is possible, but this second option, let's see, n is equal to 3, L also is equal to 3. N value must should be more than L, but here equal came. N is equal to L, not possible. That's why the answer is second option. Yes, ma. Rani, understood? Second option. How it is second option, ma? Already this kind of question earlier only we did. What is that question number? 22nd question we did. So, which set of quantum number is not possible? Lalit Kumar, not possible set does not provide a permissible wave equation. So, generally these quantum numbers, based on these quantum numbers, Schrodinger has proposed three-dimensional wave equation. The Schrodinger three-dimensional wave equation is depends on principal quantum number, azimuthal quantum number and magnetic quantum number. So, what is the relation between principal quantum number and azimuthal quantum number and magnetic quantum number? If the principal quantum number values are 1, 2, 3, 4 and azimuthal quantum number values must should be less than principal quantum number. But in the second equation, both are equal they gave. See, both are equal means it is not possible. N is equal to L, not possible. That's why this type of arrangement, the quantum numbers N is equal to 3, L is equal to 3. Like this set is not possible for a wave equation. Okay? Lalit Kumar, understood? Next, the orbital angular momentum of an electron in 4s orbital. Orbital angular momentum formula. What is the formula for orbital angular momentum? Root over L into L plus 1 into h by 2 pi. For 4s orbital, L is equal to 0. Therefore, this orbital angular momentum, just you have to substitute L value. 0 into 0 plus 1, 0 into any one is equal to 0 only. So, the resultant value is 0. So, the answer is 0. Clear? So, here directly formula ma. Yes, Nishchal, very good. See, here orbital angular momentum means the formula is root over L into L plus 1 into h by 2 pi. The spin angular momentum also the formula is present, root over 4s into s plus 1 into h by 2 pi. Okay, but here orbital angular momentum they are asked. Sir, 4s orbital L value is 0 because s L value is always 0, p L value is 1, d L value is 2, f L value is 3. So L is equal to 0 means 0 into anyone is equal to 0. So the answer is second one. Okay. Let's go for next question. The radial nodes for 3s and 3p. Radial nodes formula what ma? So nodes are two types. One is angular nodes, second one is radial nodes. The radial nodes formula is equal to n minus L minus 1. Now for 3s, n is equal to 3, L is equal to 0. Then the radial nodes for 3s is equal to 3 minus 0 minus 1 is equal to 2. And 3p, n is equal to 3, L is equal to 1. Then the radial nodes for 3p is equal to 3 minus 1 is equal to 1. So the answer is 2 comma 1. Means second option is correct. Yes ma Ashwini. Rani understood? Amruta? Chinmay present today? Chinmay? Shravana? Okay, let's see the 30th question. The quantum numbers for some electrons are in the given below. So, correct increasing order of energy of electrons. Energy, now just now only I said, energy depends on n plus L value. If n plus L value is more, the energy of electron increases. Okay, see the first one, n plus L value. A, n plus L is equal to 5, and B, n plus L is equal to 4 plus 0 is equal to 4, and C option, n plus L is equal to 3 plus 2 is equal to 5, and D option, 3 plus 1 is equal to 4. See the first option, n plus L means 4 plus 1 is equal to 5. If you are observed that the two values, the first option n plus L is equal to 5, and third option also n plus L is 5, but here n is equal to 4 and here n is equal to 3. If n is equal to more, which having more n value, it has more energy. That's why A is more energy when compared to C. Okay, next B and C you have to, B and D you have to compare. This is also 4 and this is also 4, but here n is equal to 3, here n is equal to 4. That's why B is more when compared to D. So the answer is A, C, B, D. A, C, B, D means third option is correct. Yes ma, Vivek. Abhay, understood? Vaibhav? Okay, let's go for next. '31, it's very easy, dear students. The number of lobes, okay, in most of the d orbitals. Let's see p orbitals. P orbital structure, if you are observed that dumbbell shape, it is one lobe. This is positive lobe, the second one is negative lobe. This is another lobe. So the p orbital has two lobes. The two lobes are arranged in dumbbell shape. Now come to the d orbitals. Most of the d orbitals like dxy, dyz, dzx,